Okay, so here's one more example of using optimization. So in this question, we will go through both optimizing with net benefit and optimizing on the margin using the marginal analysis to find out what is the optimal amount of driving to do. Okay, so in this simple example, right, I've got how much driving I want to do. So let's say that I drive to go visit friends, for example. So the more I drive, the more friends I get to visit, the greater the benefit. And so I've quantified the benefit here in dollars. So we've got the number of gallons of gas I use per week from driving and the total benefit I get from visiting more people in dollars. And so I need to calculate first what is the cost of using gas. And so I'm going to calculate kind of the total benefit and the total cost. But first, I say, why don't we use the marginal analysis? Because that's going to go much quicker. In fact, I don't really even have to do any complicated calculations here. So I'm just going to add something over on this column. I'm going to add two columns. So I'm going to add my marginal cost and my marginal benefit, okay, of adding additional driving, using additional gallons per week. Now, a key insight here is that my marginal cost is the change in total cost. So we can calculate the total cost of gas by taking the gallons per week times the cost of each gallon. But what I know is that every extra gallon I add, the marginal cost is going to be $2.40, the cost of that extra gallon, right? So that's very easy, right? So if I add an extra hour of time and my time is worth $15, the marginal cost is always going to be $15. So we're assuming that's constant here, right? Every gallon of gas I add $2.40 in cost. So my marginal cost is always $2.40. All the way down. So that's already a pretty easy calculation. And so now all I need to do is calculate my marginal benefit, the change in total benefit, and keep adding gallons of gas per week until that marginal benefit is no longer greater than the cost, which is $2.40. So the marginal benefit of going from 0 to 1 gallons is the change in total benefit, which is 4. 4 minus 0 is, sorry, not 0, it's 4. And so the benefit, marginal benefit of going from 0 to 1 gallons per week is $4. The cost is $2.40. I should add that first gallon of gas per week. So what about if I go from 1 to 2? My benefit increases from 4 to 8. So it's 8 minus 4 is still an extra $4 of marginal benefit. Is still greater than the marginal cost, so I should add the second gallon. What about if I go from 2 to 3 gallons per week? My benefit goes from 8 to 11. An extra $3 of benefit is still bigger than the extra $2.40 in cost. So I should go and add the third gallon. Now, what about from 3 to 4? My benefit goes up from 11 to 14. Still $3, still bigger than $2.40. So I'm going to add the fourth gallon. 4 to 5. Now my benefit has only gone up by $2, which is less than the cost, which was $2.40. So the marginal benefit is less than the marginal cost. I'm not going to add the fifth gallon. It's going to take away from my net benefit. My net benefit will go down. So if I use my marginal benefit of marginal cost, which is relatively easy to accomplish here, went pretty quickly, I would say I need to stop at the fourth gallon. I'm going to consume 4 gallons per week. That will maximize my net benefit. So let's just verify that, should we? So let's just calculate the total cost of gas for each gallon per week. Take the total benefit minus the total cost and maximize using our net benefit. So what you'll see is two things. One, we're going to arrive at the same answer. And 2, marginal benefit was much faster to calculate comparing to marginal cost. So it is the same answer, but we get it faster. I'm going to choose optimizing with marginal analysis whenever possible. So the total cost, and then I want my net benefit over here. So the total cost is gallons per week times the cost of the gallons. So it's, if we don't do anything, if we don't drive, we get no benefit, we have no cost, net benefit is 0. So when I drive 1 gallon per week, I have $2.40 in total cost. The total benefit is $4, so I have a net benefit of $1.60. 4 minus 240 equals 160. If I drive if I use 2 gallons of gas per week, my total cost is 2 times 240, or 480. So if I subtract 8 from 480, I'm going to be left with 320. Is my net benefit. Still going up. Notice by exactly the same difference between my marginal benefit and marginal cost. So if I go to 3 gallons per week, my gas cost is going to go up to $7.20. Right? So when I subtract the 11 in total benefit from $7.20 in total cost, I've got $3.80 in net benefit. And so we're still going up. So total cost of 4 gallons of gas per week is $9.60. And when I take $14 in total benefit minus the $9.60, I get $4.40 as my net benefit. What about when we go to 5 gallons of gas? We're going to be at $12 in total cost, right? So we add $2.40 to that. Gets me to $12. 16 minus 12, we're going to have $4 in net benefit. So I can keep going, right? My net benefit is going to continue to decrease, and so I'm still going to stop at this same spot, which is 4 gallons of gas per week. That will maximize my net benefit at $4.40. Okay, so that was just kind of a rehash of everything that we had learned in this chapter. Optimize with total value or net benefit, or I can optimize using marginal analysis. They both give me the same answer, but generally speaking, we find marginal benefit and marginal cost to be a faster way to solve our problem.